Hi, I'm Mike Nelson. I'd like to invite you to Basics of Confined Space, and we're going to start with Lesson 1. Before we do that, let's talk about some class rules. We are certainly going to watch some movies. We're going to complete 3 movie exercises. We're going to actually go through 4 lessons. This is the first lesson, and you'll have a quiz for each lesson. And after the course is over, you'll be submitting all 4 quizzes and the 3 movie exercises to our office. Let's get ready for lesson 1. First of all, you should be printing out the movie exercise 1 and put your name in the top. Secondly, you should print out quiz 1, put your name there on the top. Then there's a job aid, lesson 1. You may want to print that out so you can make notes on it as we go through this lesson right now. If you prefer not to print it out and just use your memory, I assume that's acceptable. Also, you're going to be bringing up the video lesson from the Dropbox so that you can go through the film and then take the movie exercise. On this video, of course, right now, you can pause it at any time and resume. So if you need to get more materials, if you need to take a break, if you need to go to work, it's okay because we can always begin again the minute you resume. So let's get started. So the lesson 1, that's going to be covering a few areas. First of all, it's going to ask the basic question, why do we even care? Why do we need this kind of training? We're going to cover a brief history of OSHA, and then we're going to see and go through some of the key definitions, not all of them. That'll be followed by you watching a movie, taking a movie exercise, and then that will be followed by actually taking the lesson quiz. So as I mentioned, why do we take this course? Well, according to OSHA, if you look at the ratio of deaths, and there's like 1,400 workplace accidents for every 1 death. But if you look closer at it and you look at confined space accidents, you'll see that for every 10 accidents, there's 1 death. So we're talking about something that's pretty serious here. Now, even though this is not absolutely current data, it's talking about a large number of fatalities in the US due to oxygen deficiency or toxic atmospheres. And again, that's confined space. The other thing that we know about confined spaces is that there may be 1 person down there who's in trouble, but by the time the rescuers show up and they do their thing, they could die as well. So very serious stuff. Approximately 60% of fatalities involve would-be rescuers. Now, here's an interesting thing. 30% of the fatalities occur in a space that has been tested and found to be safe to enter. So, in summary, why are we interested in this? Is because it's a killer. And we have to learn as much as we can about how we can protect ourselves and our fellow workers. Let's go over to the history itself. All right. And OSHA is fairly new. OSHA was started in about 1970. And their mission was to create a safer working condition for us. At the height, before they were created, there were 14,000 fatalities. Now, by comparison, maybe 5,000. So they've roughly taken at least 2/3 to 75% reduction in fatalities. So they're doing a good job, that's for sure. In 1993, they actually issued the confined space standard. And this obviously talked about establishing safe procedures and permits for entering confined spaces. You might ask yourself, well, why did OSHA develop that standard? Well, there was 122 confined space accidents each year and 173 fatalities before they started the standard. And they also, as I mentioned before, 60% of those fatalities occurred during rescue attempts. So OSHA felt that it was important to actually establish a standard. If you're curious and you wanted to know more about the history of OSHA, you could go to this website and you could get a timeline from them. Let's learn a little bit more about the standards. OSHA actually has many standards when it comes to confined space. There are 4 listed here. The one that we are interested in the most is the general industry standard. It's applicable to what we call the public sector, not the private sector, and it's certainly applicable to water and wastewater. If you wanted the exact number on the standard or reference, there it is at the bottom of the screen, right here. Now, the standard we're going to be talking about today does not apply to agriculture, construction, or ship building. So as I said, there's many different standards. Obviously, the scope of this is to set up requirements to protect employees from hazards of confined spaces. Confined space standard, in a nutshell, tries to set up or does set up a permit requirement program that you do in-house and asks the employers to do many things in that program. And that's to identify confined spaces, restrict access to them, control hazards, variety of ways using engineering practices and other methods, and continually monitoring these spaces to ensure that the hazards stay under control. Now, this is an interesting thing. OSHA administers and enforces their standards in the private sector workplace, not the public sector workplace. So in Pennsylvania, if you are in the public sector, if you're in the state sector, which is still public, OSHA would not be enforcing their regulations. The Pennsylvania Department of Labor and Industry would be. They would be administering those standards. They would do it under the general safety law that's shown here. And as I said, it only applies to the public sectors. And it does authorize them to investigate the public sector workplace safety. It also authorizes them to not only conduct investigations, but cite municipalities and sanction them and actually go into criminal penalties if they needed to. Okay. I think what I'm trying to say here, though, is that even though OSHA does not directly oversee or enforce the public sector in Pennsylvania, it would be very prudent for us to understand the standards and use those standards. That would save lives. Now, these standards, I wonder how they're organized. Well, that's how they're organized. And we're going to go through, not just in this lesson, but the other 3 lessons, many of the issues and many of the stipulations of it. Here's examples of the 12 paragraphs. We're going to cover every single area of this. We're also going to cover and show you certain things in the appendices that we think are relevant to confined space and the operation in a confined space. Question. So under the standard, what responsibilities do we have? Well, the employer wants to try to provide an area that's free of recognized hazards. Also, the employer wants to comply with the standards. Also, the employer wants to develop and implement the program, but with the help of the employees. The key here is that the more you involve the employees in developing your programs, the better and more practical these programs are going to be. Now, the employee, they have responsibilities as well. They have to comply with the standards under the Act. Now, let's move over to definitions. Definitions are very important. They're going to tell us about not only the Act, but they're going to tell us about how we will be able to operate. So we have to understand a few things before we can actually establish permit programs, etc. So now we're going to go through a series of definitions. Of course, the confined space, what is it? Well, it's large enough so you can get in it with your body to do your work. But it is limited or restricted in entry or exit. It's not like just walking into a room through a wide open door. It's certainly not designed for continuous occupancy. We know that. Okay. Now, there's another definition, non-permit confined space. These are confined spaces, but they do not contain the hazards that normally are associated with a confined space. So any of the harm or death that could occur will not occur because of some of the things that have been done in this particular space. Here's just a sample of a sign that you could see for a non-permit confined space. So the non-permit confined space does not contain additional hazards. For instance, it doesn't have any atmospheric hazards for sure, and it doesn't have any engulfment hazards where you're trapped by material. So here are some things that we can learn about the non-permit required confined space. You can access it on a continual basis. You still might be tight. It still might be tight. You do not require signage, even though I just showed you a sign. And I would also say that it's still a confined space. So you still have to really exercise caution. Now let's look at some examples of a non-permit confined space. Here I've listed 5. Now ventilated tunnels would be a very relevant one for us. There are some tunnels that we have for combined sewer overflows. We have some tunnels that we use for transmission of water in large volumes. If the tunnel is ventilated and monitored, it could be considered a non-permit confined space. And as I mentioned, there's 4 other things here that are just examples of a non-permit confined space. Now we go over to a permit confined space. This has some kind of potential to hurt us, usually a hazardous atmosphere. It may contain, and we've used this word before, engulfing, a material that could engulf us. You'll see this a lot, by the way, in grain silos, but I'll give you some other examples of engulfing pretty soon. Now, also what could happen is in this, another hazard is that the entrant could be trapped or asphyxiated by inwardly converging walls. So that would be the shape of the confined space. Now, this is an example kind of a confined space with the sloping walls. It may also have none of those, but contain some other recognized serious safety or health hazard. Say you had grouting going on and there was toxic fumes. Even if everything else was all right, and it would normally be considered a permit required confined space, because of those toxic fumes, you would consider it a toxic space. Now, the permit program itself is just that. It's a program that's set up to control and protect employees from all the hazards that are associated. It's also a program that regulates how the employees can enter these permit spaces. The permit system itself is a written procedure, and it shows exactly what we're supposed to be doing. It identifies the actual confined spaces, which ones are permit driven and which ones are non-permit driven. And it actually sets up forms and everything else like that. It's part of a permit system that we would use, okay? Now, an entry permit, that's a document that's provided by your employer, and that, again, allows the control and entry into a permit space. That would be part of your permit system. Immediately dangerous to life or health. You may see these abbreviations every once in a while, and you might be wondering what it's all about. Well, it's very serious. It means you could die from the condition that you're going to be exposed to. If not die, you could have irreversible health effects. If not that, it might interfere with your ability to actually escape from that. Okay, let's move on to blanking or blinding. What is that? That's where we'll actually close a pipe, a line, or a duct by using a bore across the entire diameter and making sure there's no leakage. Let me show you something here. So that's blinding, what we have there. And you'll notice that right here, between these two flanges, is actually a plate that's been inserted. That plate can actually withstand the temperatures and the pressures in this pipeline, and will prevent you from being injured if you're on the downstream side of that flange. Inerting, that's something that we really don't do too much. And that really is where you've got a combustible atmosphere and you still have to do work in there. In order to do that, you actually inert the area. And a very typical way of doing that is using nitrogen. By the way, if you do this and you do inert the area, now you have no oxygen in there. So it's a very dangerous situation. I wouldn't recommend doing this unless you had a lot of training. Here's the inerting. Over here, before we inert, we have oxygen, and we have heat, and we have fuel, and you have a reaction. Here, you have nitrogen, you have heat and fuel, and you will not have a combustion reaction. Emergency, again, the emergency could occur in your confined space, near your confined space, and it could be causing you to have to abort your mission in the confined space. A very simple example would be that if any of your monitors fail, you have to shut down the operation and get the folks out of that sewer or whatever the confined space might be. And again, you've seen this word engulfment many, many times. And basically, it's something like let's pretend that it was quicksand. Quicksand will engulf you. And when it engulfs you, it will actually start plugging up your respiratory system. Eventually, it's going to get in your mouth and your nose. It's going to plug it up. You're not going to breathe. It's not going to be very good. Okay. The other thing that can happen is it can exert force on your body. It can strangulate you. It could crush you as well. So engulfment's not a fun thing, that's for sure. You'll see it a lot in grain elevators. We don't do much in grain elevators in our industry, but in grain elevators, sometimes an employee will get in there and not have the right safety harnesses. And all of a sudden, the screw conveyor will be working here, pulling out grain. And what happens is it starts to pull the person down into the grain, and actually death will occur. Now let's talk about other examples though of engulfment. Drowning, flooding of a confined space, being swept away in a storm sewer or combined sewer. This is where water is engulfing you and you still die. A cave-in is engulfment. Sloping sides, they let go for some reason. Now all that soil is probably being compressed or compressing your body parts. You can't breathe. Not a good situation. So it's technically engulfment. Entry, that's an easy one. Okay? The person passes through into the confined space. More about entry. It really occurs the minute a part of your body breaks the plane of that confined space. So in this particular example, even though the individual's breathing outside air, eyes are seeing the air, everything, right now, they are considered entering the confined space. Acceptable entry conditions, that's an easy one. All right, what conditions do we want to safely, to make sure our employees are safely entering into the workspace? Okay. An attendant, that's pretty straightforward. They're stationed outside. Their job is to monitor what's going on with the entrance. I'll talk about the entrance in a second. And perform other duties that are involved with the permit program. The entrant, that's the person who's going down in. The supervisor, of course, they're responsible for making sure the conditions are okay, authorizing the entry itself, watching the whole operation, and then terminating it as well. Hazardous atmospheres exposes employees, right, to death, incapacitation, the impairment to self-rescue. In other words, someone else has to pull you out of there, injury, and of course, acute illness. Hazardous atmospheres, if you have a flammable gas, it can be hazardous. And it's probably above the lower flammable limit By the way, we also call that the LEL, the lower explosive limit. Here's something I'm not sure you know, but dust can also be explosive. So we have to be careful that if we are, and this happens a lot in, again, grain elevators and places like that, where you have a lot of dust, that dust can actually be combustible. So we have to watch out for that as well, because some of the spaces we're in could be pretty dusty. It doesn't have to be a sewer. It could be a confined space, maybe in an incinerator building where there's lots of ash and dust floating around. Now, as I mentioned before, that you see the term LFL. We usually say LEL, lower explosive limit, but you might see it once in a while. It's the same thing. And here, what this diagram is showing you is that if you're below the lower explosive limit, which is usually about 10%, you're going to be okay. In this zone here, from the lower explosive limit to the upper explosive limit, UEL, you're not going to be okay. If you get above the UEL, the upper explosive limit, it's too rich for combustion. It will not explode. Now, I wouldn't take a lot of comfort in that, because if it's above that and you go in and start ventilating, you're going to drive it down to this area and have an explosion. So the key thing is this, the lower explosive limit. That's what we really want to work on, and we want to monitor for sure. Another thing about the atmosphere is how much oxygen do we have? We need oxygen to live. If we don't have 19.5% of oxygen, our performance is going to suffer. And later on in the next lesson, I'll probably show you how it will suffer. If it's above 23.5, that's called an enriched environment. That's no good either. I know it, you would think, hey, it's great to have more oxygen, but it's not, because it actually increases the flammability of many materials. So we have to be careful about that as well. Now, isolation, we had a slide before, we talked about blinding and blocking, and we really have to, in some confined spaces, there's things in there, pipelines in there, electrical lines in there, that could hurt us. So we have to figure out ways to isolate ourselves from those sources of energy and sometimes materials. For instance, it could be a very high pressure water main that if it broke, it would fill up the hole so quickly you couldn't even get out. Okay. So some of the techniques that are used, and I talked about this already, the blanking and the blinding, misaligning. I'll show you what we mean by that in a second. Double block. Lockout, tag out, we're all familiar with that, and I'll go through that just a small bit. And of course, mechanical linkages. Now, blocking a mechanical linkage would be, for instance, if you had a spring-loaded machine, well, it's okay to shut it off, and it's okay to remove all the power, but the spring may still have power in it. And for some reason or other, if that spring is not locked or blocked, it could be hurting you at the wrong time. This diagram shows you some of the things we do to control energy. Now, we didn't really talk about grounding energy too much or electrical, but yes, we want to make sure that we are using a tool and not getting the electricity flowing through us. We'd rather it flow through ground. Blank or blind, we showed you a diagram about that already. Double block and bleed is they're blocking from both sides and you're bleeding here. Sometimes you'll just misalign the pipe on purpose so that you cannot, let's say if you're working downstream here, the flow's going this way, well, the flow's not going to get to you. And then, of course, if you remove a spool piece, that's the same thing will happen. If the flow is here and you're working in a confined space, excuse me, over here, this way it will not get to you. Of course, we have lockout, tagout to deal with. And here we're listing 5 different things that we would lock and tag out. These are all types of energy that we have to worry about. And we have to protect ourselves. We have to protect ourselves whether we're in a confined space or not, but from these types of energy. But if you're in a confined space, you don't have a lot of ways to escape. You don't have many options. And if you're exposed to a chemical or a hydraulic leak or steam, your chances of being injured are much higher. Line breaking, that's another way that we can stop and protect ourselves from pipelines and ducts that are running through a confined space that we have to work in. And that's intentionally opening up that pipe. That's as simple as it is, so that it's not going to come to you. Here again, we're talking about the oxygen deficiency. I don't have to talk about it too much more. We've already mentioned the 19.5 and the 23.5%. But again, in the next chapter, I probably will spend a little bit more time on this. Here's your retrieval system. That's another thing that we want to define. And that is used so that you can move tools and people in and out of a confined space. And we normally break it down into a few components. I mean, you actually have the tripod itself, but you have the retrieval lines. You usually have a harness. You'll have a lifting device. You'll have an anchor, and the anchor is actually like up in here, and that's really for fall protection. That's not going to allow the worker to fall too fast, too far. And that's what the anchor is doing for you. Testing, okay, we want to understand that. That's pretty easy. That's where we are actually checking to see if we do have any problems with that confined space. If we have problems, then we have to try to solve them, eliminate them, reschedule the job, whatever. Now, testing makes sure that we protect the entrance. And we make sure that we have acceptable entry conditions. Look at this, prior to and during entry. In other words, we're not just going to measure once. We're going to measure a whole lot of times to make sure that we're testing the right way. Okay, now it's movie time. So I want you to go to your class Dropbox, open up the video folder, open movie number 1, watch the movie. While watching the movie, follow along and complete the movie exercise that you already printed out. Make sure that you do the extra credit question too. Now, after you've seen all 3 movies, those 3 of them in this whole course, then we're going to ask you to take them all and submit them to our office. Now that concludes the material for lesson 1. Now what you want to do is you want to do the lesson 1 quiz, including the extra credit questions. If you recall, to get ready for lesson 1, you actually printed out the quiz. So now you put your name on it and you take the quiz. And again, make sure that you get that extra credit question, you get that done. When you complete all 4 quizzes, there are 4, 1 for each lesson, then please submit them to our office. Now, just to warm you up, for lesson 2, which is going to be a separate video, let me explain what you want to do. You want to be, first of all, you want to print out the second movie exercise, put your name on the top. You want to put your name on the top of the quiz, print that out. You have a job aid, lesson 2. You can print that out if you'd like and then make notes on it as we go along. You also get your video lesson number 2 ready from the Dropbox because that's going to be part of our lesson 2 today. Reminding you again that you can pause the video. Once you start lesson 2, you can pause it at any time, get papers that you need, references, take a break, start the next morning on it, go to work, whatever. That's what is the advantage of this kind of a presentation. So we're not going to get started now, but I'm just trying to warm you up for lesson 2.